10,000 years after the last dire wolf walked the earth, scientists say they've now brought them back.
What if extinction wasn't the end, but just a pause? Around the world, scientists are unlocking ancient DNA, using groundbreaking gene editing and bold innovation
Come on. Come on.
to bring long-lost species back from the dead. Creatures that vanished centuries or even millennia ago are now the focus of real-world resurrection efforts.
We've peered into a fascinating world of extinct species.
And this isn't just theory. The dire wolf, that fierce Ice Age predator, has already been revived through genetic engineering. These are the 16 extinct animals that scientists want to revive. Number 16, the cave lion, Ice Age royalty poised for a comeback. Imagine a lion standing 5 feet tall at the shoulder with a thick, shaggy coat to ward off the biting cold. That's no fictional beast. That's the cave lion, a majestic feline that once ruled the ancient world during the Pleistocene epoch. These formidable predators roamed the grasslands and forests of Europe and Asia, hunting mammoths, deer, and other Ice Age giants. But as the world changed, the cave lion vanished, leaving behind only fossilized remains. But what if we could bring this regal creature back from the depths of extinction? That's precisely what scientists are working towards, thanks to the exceptional preservation of cave lion remains in the frozen wasteland of Siberia. Cave lion cubs have been discovered with their soft tissue, fur, and even internal organs perfectly preserved by the permafrost. This remarkable conservation provides researchers with the valuable genetic material needed to attempt resurrection. The cave lion's close genetic proximity to modern lions offers another advantage in the quest for de-extinction. By comparing the cave lion's genome to that of its living relatives, scientists can identify the key differences and potentially edit the genes of modern lions to create a cave lion-like creature. This process, known as gene editing, could allow the cave lion to roar once more, with modern lionesses serving as surrogate mothers to carry the resurrected cubs. Number 15, the dodo, undoing a symbol of extinction. On a remote island in the Indian Ocean, a peculiar bird once roamed freely, blissfully unaware of the fate that awaited it. The dodo, a flightless bird with a plump body and a large hooked beak, has become the poster child for extinction. Hunted to oblivion by sailors and ravaged by introduced predators, this gentle giant disappeared from the face of the earth in the late 17th century, just decades after its discovery. But now, nearly 400 years after its untimely demise, the dodo may be getting a second chance at life. Colossal Biosciences, a trailblazer in the field of de-extinction, has set its sights on resurrecting this iconic bird. By comparing the reconstructed genome of the dodo with that of its closest living relative, the Nicobar pigeon, scientists are unraveling the genetic blueprint of this long-lost species. The plan is audacious yet simple. Edit the Nicobar pigeon's DNA to incorporate key dodo characteristics, essentially creating a hybrid bird that embodies the essence of the dodo. From its distinctive beak to its bulky frame, the resurrected dodo would be a mirror image of its extinct ancestor, adapted to thrive in the lush forests of Mauritius once more. Number 14, the dire wolf, a howl from the past. In the frozen wastelands of the Pleistocene, a bone-chilling howl pierced the night sky. The dire wolf, North America's dominant predator for over 1 million years. More robust than modern wolves with crushing jaws and powerful limbs, these formidable hunters brought down bison, horses, and ground sloths across Ice Age landscapes, leaving thousands of fossilized remains in places like the La Brea tar pits as haunting evidence of their once widespread reign. For 10 millennia, these apex predators existed only as museum specimens in scientific papers, an evolutionary branch thought lost forever when the megafauna they hunted vanished from the Americas. Unlike other extinct species with living close relatives, dire wolves were believed to represent a distinct lineage that disappeared completely, leaving no direct descendants in our modern world. April 2025 changed everything. In a breakthrough merging paleogenomics with precision genetic engineering, scientists unveiled 3 living wolf pups carrying traits of their long-extinct ancestors: 6-month-old males Romulus and Remus, and 2-month-old female Khaleesi. These animals represent not merely scientific curiosity, but a fundamental reimagining of extinction's permanence. The achievement followed a remarkable technical journey. Researchers first extracted and sequenced dire wolf DNA from 2 exceptionally preserved specimens, a 13,000-year-old tooth and a 72,000-year-old ear bone. By methodically comparing these ancient genomes with that of the modern gray wolves, the scientists identified specific genetic differences responsible for the dire wolf's distinctive characteristics. Rather than attempting direct cloning, impossible with degraded ancient DNA, the research team took a more innovative approach. They precisely edited gray wolf genetic sequences to express key dire wolf traits, then implanted these modified embryos in domestic dog surrogates. The resulting pups, while technically modified gray wolves rather than pure dire wolves, exhibit the broader skull structure, enhanced jaw strength, and robust build that made their Ice Age counterparts such effective predators. Number 13, the Woolly Mammoth, a Titan's return. Picture a behemoth, towering 13 feet tall at the shoulder, with massive curling tusks and a shaggy coat that brushes the ground. This is the woolly mammoth, a majestic creature that once roamed the frozen tundra of the Pleistocene. For thousands of years, these gentle giants were the undisputed rulers of the Arctic, adapted to survive in some of the harshest conditions on Earth. But now, after lying dormant in the permafrost for millennia, the woolly mammoth is on the verge of a remarkable comeback. At the forefront of this groundbreaking endeavor is Colossal Biosciences, a company dedicated to pushing the boundaries of de-extinction. By harnessing the power of cutting-edge genetic technologies, scientists are working to create a mammoth-elephant hybrid, a creature that embodies the best of both species. The process is a delicate dance of science and innovation. By carefully selecting traits from preserved mammoth DNA and splicing them into the genome of the Asian elephant, researchers are crafting a new species, one that is adapted to thrive in the rapidly changing Arctic landscape. The resulting hybrid, affectionately dubbed the mammophant, will possess the woolly mammoth's thick, insulating coat, its massive size, and its resilience to cold, while retaining the Asian elephant's social structure and adaptability. But the mammoth's resurrection is more than just a scientific marvel. It's a beacon of hope in a world grappling with climate change and habitat loss. By reintroducing these keystone species to their ancestral homes, scientists aim to restore the delicate balance of Arctic ecosystems, helping to mitigate the effects of melting permafrost and rising sea levels. Number 12, the Tasmanian Tiger, a marsupial marvel's last stand. The thylacine, mistakenly called the Tasmanian Tiger, despite being neither tiger nor true wolf, was nature's masterpiece of convergent evolution. This unique marsupial predator evolved a striking wolf-like appearance while carrying young in a pouch like its kangaroo cousins. With jaws that opened to an astonishing 120-degree angle and distinctive sandy stripes crossing its lower back, this carnivorous marvel stalked through eucalyptus forests and windswept grasslands for millennia, becoming woven into the spiritual tapestry of indigenous Australian culture. European colonization proved catastrophic for this remarkable hunter. Falsely blamed for livestock deaths and placed under government bounty, the thylacine faced relentless persecution while its habitat shrank and introduced dogs competed for prey. The species collapsed with shocking speed, and despite belated protection efforts, the final known thylacine, ironically named Benjamin, died alone and unfilmed at Hobart Zoo in 1936, ending a lineage that had persisted for 4 million years. Now, in an extraordinary scientific reversal, cutting-edge genomics has rekindled hope for the thylacine's return. By 2017, researchers successfully sequenced its complete nuclear genome, establishing the blueprint for resurrection rather than merely documenting what was lost. The extinct predator might soon slip from the realm of memory back into living forests. In 2022, A groundbreaking partnership between the University of Melbourne and Colossal Biosciences accelerated this ambitious de-extinction project. Their revolutionary approach involves editing the genetic code of the thylacines' closest living relative, the tiny fat-tailed dunnart, to express the traits of its vanished cousin. Progress has been remarkable, with scientists announcing in late 2024 the reconstruction of a nearly complete thylacine genome from a century-old preserved skull. Perhaps most impressive, early 25 brought the unveiling of an artificial marsupial womb, a technological marvel designed to nurture the first newborn thylacines, while simultaneously advancing conservation for endangered pouched mammals throughout Australia. With experts projecting the first living thylacine could appear as early as 27, the distinctive yap of this striped phantom may soon echo through Australian wilderness once more, writing a new chapter in conservation history. Number 11. The moa, a feathered giant's second chance. In the misty valleys and rugged mountains of New Zealand, a shadow of a forgotten era once dominated. The moa, colossal flightless birds that stood up to 12 feet tall. These feathered behemoths ruled New Zealand's pristine wilderness as living embodiments of island evolution's extraordinary potential. For countless millennia, their distinctive booming calls echoed through ancient forests, their massive forms browsing vegetation unreachable to other creatures as they shaped the very ecology of their isolated island home. The arrival of Maori settlers 700 years ago spelled catastrophe for these gentle giants. Without evolved fear of mammalian predators, moas proved tragically vulnerable to hunting. Their enormous eggs, slow reproduction, and trustful nature made them perfect targets. Within a mere century, an evolutionary eye blink, all 9 moa species vanished completely, representing one of history's swiftest extinctions. The once dominant rulers of New Zealand's ecosystems disappeared so thoroughly that European colonists initially dismissed indigenous accounts of these birds as mere legends. Now, centuries after their extinction, cutting-edge genomic science offers an unprecedented possibility, bringing the moa back to the misty forests they once called home. In a breakthrough announcement, scientists at Harvard University recently assembled the first nearly complete moa genome using DNA painstakingly extracted from preserved toe bones. This genetic blueprint brings these vanished giants one crucial step closer to resurrection. Unlike other de-extinction candidates, the MOA has powerful advocates within its homeland. Trevor Mallard, a prominent New Zealand politician, has championed the return of a medium-sized moa species as both scientifically possible and ecologically beneficial for restoring lost forest dynamics. Using the emu, the moa's closest living relative, as a genetic proxy, scientists believe they could potentially recreate a creature that reflects the moa's unique characteristics while fulfilling its ecological role. Number 10. The passenger pigeon, resurrecting a lost legacy. A haunting absence fills North America's skies, a void once occupied by the passenger pigeon, nature's most spectacular abundance. These weren't merely birds, but biological phenomena. Copper-breasted flocks stretching 100 miles, creating rushing shadows across forests as billions of wings block the sun. Their numbers exceeded all waterfowl in North America today combined. So numerous were these creatures that they shaped entire forest ecosystems, their droppings fertilizing vast woodlands, while their feeding habits transformed the very composition of America's eastern forests. This extraordinary abundance collapsed with devastating speed. Commercial hunters tracked flocks via telegraph and shipped millions of slaughtered birds to urban markets on newly built railroads, while expanding settlements devoured forest habitats. Within a single human lifetime, the most numerous bird on the continent vanished completely. The final wild passenger pigeon fell to a hunter's shot in Ohio in 1900, and 14 years later, Martha, the last living individual, died in her Cincinnati zoo cage, ending a species that had shaped eastern forests for millennia. Over a century after this ecological catastrophe, genetic science now offers an audacious possibility: resurrection. The nonprofit Revive and Restore has extracted DNA fragments from museum specimens, not for simple cloning, impossible with such degraded material, but to identify specific genetic differences between passenger pigeons and their closest living relatives, band-tailed pigeons. By modifying these key mutations, scientists aim to recreate not just the appearance, but the essential biological traits that made these birds ecological keystone species. Recent breakthroughs have accelerated this ambitious timeline. In October 2024, Revive and Restore and the Applied Ecological Institute initiated forest disturbance simulations in Wisconsin, studying how woodlands would respond to the bird's eventual return. Laboratory work has progressed in parallel, with scientists now projecting that the first captive-bred passenger pigeons could hatch between 2029 and 2032. The ultimate vision, passenger pigeons once again darkening American skies, remains decades from realization. Number 9. The Sabertoothed Tiger, a fearsome feline's return. In the shadows of the Pleistocene, a fearsome predator stalked the Americas, striking terror into even the mightiest prey. With its powerful build, immense size, and elongated saber-like canines, the saber-toothed tiger reigned as an apex predator for millions of years. Its evolutionary mastery displayed through remarkable adaptations, perfectly suited to its ecosystem. As the climate warmed and landscapes transformed during the late Pleistocene, this magnificent feline faced insurmountable challenges. Declining large herbivore populations, increased competition from other predators, and human hunting pressure led to its extinction in a mere geological moment. For millennia, the saber-toothed tiger existed only in fossils and imagination, until a groundbreaking discovery changed everything. In 2020, researchers unearthed an astonishingly well-preserved 35,000-year-old mummified saber-toothed tiger from the frozen permafrost of northeastern Yakutia, Russia. This exceptional specimen, with its intact dark brown fur measuring 20 to 30 millimeters long, provides researchers with unprecedented access to genetic material that could revolutionize de-extinction efforts. Scientists now believe modern felids, such as lions or tigers, could serve as surrogates, with embryos modified using CRISPR technology to incorporate saber-tooth traits. Surprisingly, the humble domestic cat, despite its diminutive size compared to its ancient relative, has emerged as the keystone species in this ambitious resurrection project. Genetic analysis reveals that today's house cats share remarkably preserved genetic pathways with their prehistoric cousin, making them ideal DNA donors for reconstructing missing genetic sequences. This unexpected connection between purring pets and prehistoric predators has positioned the domestic cat as the crucial bridge between past and future, potentially enabling scientists to decode vital genetic information that larger modern cats cannot provide. This breakthrough discovery has reignited the possibility that this iconic predator might once again walk the earth after 10,000 years of absence. Number 8. The Pyrenean Ibex, a second chance for a mountain monarch. High in the rugged peaks of the Pyrenees, a ghostly presence lingers, a specter of a vanished era, when the clatter of hooves and the clash of horns echoed through the mountain valleys. The Pyrenean Ibex, a majestic wild goat with sweeping horns and a regal bearing, once roamed these highlands in abundant numbers, a true monarch of the mountains. But the hand of fate can be cruel, and in a twisted turn of events, the Pyrenean Ibex became the first species to be driven to extinction twice. First by overhunting and disease in the wild, and then by the tragic failure of a cloning attempt that sought to bring it back from the brink. The last known Pyrenean Ibex, a female named Celia, died in 2000, marking the end of a species that had endured for thousands of years in the face of countless challenges. But even as the world mourned the loss of this mountain monarch, scientists were already hard at work, seeking to unravel the secrets of its genome and find a way to bring it back from the depths of extinction. In a groundbreaking experiment, researchers used DNA extracted from preserved skin samples of the Pyrenean Ibex to create a clone, a genetic twin of Celia, that offered the tantalizing possibility of a second chance for this lost species. But the road to de-extinction is fraught with peril, and the cloned Pyrenean Ibex, born in 2003, survived for a mere 7 minutes before succumbing to lung defects. It was a heartbreaking setback, a stark reminder of the immense challenges that lie ahead in the quest to bring vanished species back from the brink. But even in the face of such adversity, the dream of resurrecting the Pyrenean Ibex lives on. Fueled by advances in genetic technology and the tireless dedication of scientists who refuse to let this mountain monarch fade into the annals of history. Number 7, the Quaga, painting a new portrait of the past. A living canvas that blurred the line between familiar and fantastical once roamed South Africa's sun-drenched grasslands. The quagga, with bold stripes adorning only its head, neck, and forelegs, before fading into a plain brown rump, appeared as though nature had started painting a zebra, but abandoned its brush halfway. This distinctive subspecies of plain zebra moved in vast herds across Cape Province, embodying wild beauty in its most unique form. European settlers, viewing these animals as competitors for precious grazing land, hunted them with ruthless efficiency. By the mid-19th century, wild populations had vanished completely. The last captive quagga died quietly in Amsterdam Zoo in 1883, a creature that once numbered hundreds of thousands, slipping into extinction almost unnoticed until too late. Unlike most vanished species, the quagga harbored a biological secret that would eventually offer an unprecedented second chance. It wasn't a separate species, but merely a color variant of the still abundant plains zebra, differing primarily in its distinctive striping pattern rather than its fundamental genetic makeup. This crucial distinction inspired the Quaga Project's formation in 1987, a revolutionary conservation initiative unlike any attempted before. Rather than using complex genetic engineering, the project embraced the elegantly simple approach of selective breeding. Scientists identified plain zebras that naturally displayed reduced striping on their hindquarters, a trait occasionally appearing in normal populations, and systematically bred these individuals across successive generations to recreate an animal visually indistinguishable from the vanished quagga. After decades of careful selection, the project has achieved remarkable success. The latest animals, called Rao quaggas, after the project's founder, display striking similarities to museum specimens of their extinct ancestors. While debate continues about whether these animals are genetically identical to historical quaggas, plans progress to release herds into the Western Cape, the quagga's ancestral homeland. Number 6, the Steller's sea cow, a gentle giant lost to human greed. In the icy waters of the North Pacific, a gentle giant once grazed upon abundant kelp forests, blissfully unaware of the dark fate awaiting it. The Steller's sea cow, a colossal marine mammal related to modern manatees and dugongs, was truly awe-inspiring. Measuring up to 30 feet in length and weighing as much as 10 tons, this docile herbivore thrived in frigid Arctic waters thanks to a thick, rubbery hide insulating its massive form from the cold. The sea cow's peaceful existence was shattered with the arrival of Russian fur hunters in the Commander Islands. These enormous creatures, unable to submerge completely and tragically unafraid of humans, presented an irresistible target. Slaughtered for their calorie-rich blubber, tasty flesh, and valuable hide, the population collapsed with shocking speed. Just 27 years after Georg Wilhelm Steller first described them to Western science, the last confirmed Steller's sea cow was killed in 1768, representing one of history's swiftest documented extinctions. Now over 250 years since their disappearance, a remarkable scientific breakthrough has rekindled hope for these vanished ocean giants. In 2021, researchers successfully sequenced the complete nuclear genome of the Steller's sea cow from preserved remains, unlocking the genetic blueprint that made these creatures unique. Building on this momentum, an ambitious team of Russian scientists launched a formal de-extinction project in late 2022, focused on resurrecting and eventually reintroducing these marine behemoths to their former Arctic range. Their approach centers on editing the genome of the dugong, the Steller's sea cow's closest living relative, to express the traits that enabled these giants to thrive in cold northern waters. Number 5, the woolly rhino, a prehistoric tank. Imagine a tank on 4 legs, armored in thick, shaggy fur, and crowned with a pair of massive horns. This is the woolly rhinoceros, a prehistoric behemoth that once roamed the frozen steppes of Europe and Asia. Standing 6 feet tall at the shoulder and weighing up to 5,000 pounds, this Ice Age giant was a force to be reckoned with, adapted to survive in some of the harshest environments on Earth. But now, thousands of years after its extinction, the woolly rhino is poised for a remarkable comeback. Thanks to the discovery of well-preserved fossils in the permafrost of Siberia, scientists have been able to extract high-quality DNA from these ancient remains. By comparing the woolly rhino's genome to that of its closest living relative, the Sumatran rhinoceros, researchers are unraveling the secrets of this long-lost species. The woolly rhino's resurrection demonstrates the extraordinary power of modern science. By carefully selecting and modifying genes from the Sumatran rhino and splicing them into the woolly rhino's genome, scientists are creating a new species, one that captures the strength and resilience of its prehistoric ancestor. The resulting hybrid will possess the woolly rhino's thick insulating coat, its massive size, and its formidable horns, while also benefiting from the Sumatran rhino's adaptability and resistance to disease. Number 4, the Irish elk, a majestic phantom of the Ice Age. Picture a deer standing 7 feet tall at the shoulder, with antlers spanning up to 12 feet from tip to tip. This is no ordinary deer. This is the Irish elk, a magnificent creature that once roamed the plains and forests of Eurasia during the Pleistocene epoch. With its towering stature and impressive antlers, the Irish elk was a sight to behold, a true giant among the megafauna of the Ice Age. But despite its name, the Irish elk was not confined to Ireland alone. Its range stretched from Siberia to the British Isles, encompassing vast swaths of Europe and Asia. For thousands of years, these majestic creatures thrived in the cold, harsh environments of the Pleistocene, adapted to survive on the grasses and shrubs that dominated the landscape. However, around 7,000 to 8,000 years ago, the Irish elk vanished from the face of the earth. The exact causes of its extinction remain a mystery, but scientists speculate that a combination of climate change, habitat loss, and human hunting pressure may have played a role. As the world warmed and the Ice Age came to an end, the Irish elk's preferred habitat began to disappear, leaving these giants with nowhere to turn. But now, thanks to the wonders of modern science, the Irish elk may be poised for a comeback. Well-preserved remains, including soft tissues and even intact antlers, have been discovered in the bogs and permafrost of Eurasia. These fossils contain valuable DNA, the genetic blueprint of the Irish elk, which scientists can use to attempt de-extinction. By comparing the Irish elk's genome to that of its closest living relatives, such as fallow deer and red deer, researchers can identify the key traits that made this ancient giant unique. Using cutting-edge gene editing techniques, they can then splice these traits into the genomes of modern deer, essentially creating a hybrid animal that embodies the essence of the Irish elk. Number 3, the Doticurus, a prehistoric tank reborn. Imagine a behemoth clad in bony armor, with a club-like tail capable of shattering predator bones. The Doticurus, not fantasy, but a real prehistoric relative of today's armadillo. This South American giant weighed 3,000 pounds, stood 5 feet tall, and stretched 12 feet long during its reign in the Pleistocene epoch. Its most formidable feature was a cannonball-heavy tail tipped with lethal spikes, weighing 88 pounds. Despite being a peaceful plant eater, this natural wrecking ball made the Doticurus virtually untouchable to predators of its time. As the Ice Age ended 7,000 years ago, changing climates erased the Doticurus's habitat, and the armored colossus vanished, leaving only fossilized remains as testimony to its existence. Unlike dinosaurs, whose extinction occurred millions of years ago, the Doticurus's relatively recent disappearance creates a unique opportunity for de-extinction science. Researchers now search cool, dry environments for preserved genetic material, hoping to bridge the gap between this prehistoric tank and its modern descendant, the humble armadillo, 300 times smaller than its impressive ancestor. This living connection offers scientists a genetic blueprint for potentially resurrecting the Doticurus. By mapping differences between contemporary armadillos and ancient remains, researchers believe they could bring this armored giant back to life, returning a magnificent piece of the Pleistocene to our modern world. Number 2, the ancient bison, a primordial beast reborn. In the midst of prehistory, a primordial beast roamed the vast expanses of North America, its presence embodying the awesome power and majesty of the natural world. Standing up to 8 feet tall at the shoulder and weighing over a ton, the ancient bison, or Bison antiquus, was a sight to behold. A shaggy, horned colossus that dwarfed its modern-day descendants and evoked images of a long-lost world where giants still walk the earth. For tens of thousands of years, these magnificent creatures thrived, their thundering herds shaping the very landscape itself as they grazed and trampled their way across the continent. But the march of time is relentless, and as the world shifted and changed, the ancient bison found itself facing challenges it could not overcome. The warming climate and changing vegetation patterns of the late Pleistocene saw the decline of the lush grasslands that had sustained these behemoths for so long, while increased hunting pressure from human populations and competition from other large herbivores added to the strain. In a geological heartbeat, the ancient bison vanished from the face of the earth, its reign as one of North America's most iconic megafauna cut tragically short. Now, some 10,000 years after the last ancient bison breathed its final breath, the prospect of its return is electrifying scientists and capturing the imagination of people around the world. Advances in genetic technology and the wealth of knowledge we have accumulated about the reproductive biology of modern bison have opened up the tantalizing possibility of bringing this primordial beast back from the depths of extinction. By carefully studying the preserved remains of ancient bison and comparing their DNA to that of their living relatives, researchers hope to identify the key traits that set these giants apart and use that knowledge to effectively resurrect the species. Number 1. The gastric brooding frog, a vanished marvel of motherhood. In the misty rainforests of Australia, a peculiar amphibian once thrived, harboring an astonishing secret within its belly. The gastric brooding frog, a marvel of evolution, had developed a unique adaptation that pushed the boundaries of parental care to the extreme. Females of this species would swallow their fertilized eggs, transforming their stomachs into living nurseries where their offspring would develop, safe from the perils of the outside world. Tragically, this extraordinary frog vanished from the face of the earth in the 1980s, a victim of the relentless march of human progress. Habitat destruction, pollution, and the insidious chytrid fungus all played a role in the gastric brooding frog's untimely demise, silencing its distinctive call and erasing its presence from the lush forests it once called home. But now, decades after its disappearance, a glimmer of hope has emerged. Scientists, armed with cutting-edge genetic tools and an unwavering determination, are embarking on a bold mission to resurrect this lost species. By extracting DNA from preserved specimens and leveraging the power of cloning technology, researchers are working tirelessly to bring the gastric brooding frog back from the brink of oblivion. Thanks for watching, and we'll see you in the next one.